Hey everyone, this is Miss Turk. I'm going to go over some hints for the 1.5.3 test. So 1A, you can look at 1.1.1 page 4. 1B, all same space. 1C is in a much different area of the textbook. It's in 1.3.3 page 4. And D is 1.1.1 page 6. And then this question, you don't really need to look in the book as long as you know how to read, read the diagram. So you just go like over to 100 degrees and up to, kind of approximate where 2 atm would be and tell me what phase. When they say phase, they mean solid, liquid, or gas. And then B and C are asking what happens to water, and they're asking for the name of a phase change or a change in state. So you either need to say it boils, it condenses. Boil is liquid to gas, condenses is gas to liquid, freezes is solid to liquid, and melts is liquid to solid. So go through this change, like find 100 degrees at 0.8 atm, then find 100 degrees at 1.2 atm, and notice what it passes into, okay? So if it's going from solid to liquid, you would say it's melting. And then same thing for this, okay? So if it was going from, liquid to gas, you would say it's boiling. And then for part D, what line represents boiling points? It's the boiling point is represented by the border between liquid and gas. Okay, like right here. So yeah, that should be the border of the liquid and gas areas. And the next one, what question number is this? E, it's 1.1.1, page 17. Okay, and then question 3 is all about the different types of solids. So you can look at 1.1.3, pages 4 through 12. Okay, so this draws from a large swath of the textbook, and that's part of that as well. Question 4, A is 1.2.1, page 3. B, the first part of B is 1.2.1, page 9. The second part of part B, I want you to omit that. I didn't see that anywhere in the book. And then for C, the first part, 1.2.1, page 12. And the second part, 1.2.1, page 13. All of this stuff is 1.2.1, page 18 to 19. And then question 5, they want you to order them from highest melting point to lowest melting point. So the one with the highest melting point, you're going to give it number 1. Okay. And there are 4 things in this list. The lowest melting point, you're going to give it a number 4. So the lowest melting point is the one that melts the easiest. The highest melting point is the one that's the hardest to melt. So that is 1.2.3, page 4 to 6. And then B is 1.2.3, page 10. C is 1.2.3, page 16 and 18. For part D, okay, rice is difficult to cook at high altitudes due to the lower pressures. Use this fact to answer the following questions. So as you go up in the mountains, the air gets thinner and thinner, and the atmospheric pressure gets lower due to the thinner air. So when there's less air and less atmospheric pressure pushing down on your water that you're trying to boil, it's actually easier for the water to boil. So think of it as less air pushing down means it's easier for the water to turn into a vapor and go up, okay? So instead of boiling at 100 degrees Celsius like water normally does at sea level here, when you get up into the mountains, like if you were to climb Mount Everest, at the top of Mount Everest, water boils at 68 degrees Celsius, just because there's less air pressure pushing down. So that means the boiling point of water is lower because it's easier for the water to boil. So you could go on Mount Everest and boil water and stick your hand in it and not get burned, because it would look just like boiling water looks here, but it's boiling at a much lower temperature due to the lower atmospheric pressure. So I don't think that was clearly explained in the text. And then part 2, what would adding salt do to the boiling point? 1.2.3, page 18. And then part 3, okay, this is the formula they want you to use. Delta means change in, and TB is the temperature of boiling, or the boiling point. So this is the change in the boiling point. How much the boiling point changes when you dissolve something in a liquid is equal to I times KB times the molality, okay? I'll explain what those mean in a second. So it's asking to change the boiling temperature by 5 degrees. So the change in the boiling temperature is going to be 5 degrees Celsius, okay? I has to do with the number of particles that the substance breaks into. So this is NaCl, and because that's ionic, when NaCl dissolves, it breaks apart into two different ions, the Na positive and the Cl negative. So the value for I is 2. For something like sugar that's not ionic, the value for I is just 1 because it stays intact. It's just one particle, okay? So it's just like for each formula unit, how many particles does it break into? For NaCl, it's 2. Kb is something that's unique to the solvent, which in this case is water. So Kb for water is 0.51 degrees Celsius per mole, and this is actually times Kelvin, okay, or mole, oh sorry, this should be times kilograms. So degrees Celsius is on the top of the unit, moles is on the bottom, and kilograms is on the bottom of the bottom, which means you flip it to the top, okay? So it's 0.51 degrees Celsius times kilograms per mole. And then the molality is the moles per kilogram. Okay, and we have 1 kilogram. Okay, so we know the kilograms of water. We just need to figure out how many moles. So I'm going to call this X number of moles. Okay, and that's a times sign. So moles is going to cancel because it's on the top and bottom. Kilograms will cancel. Okay, and we're left with degrees Celsius over here and degrees Celsius over here. So I'm going to simplify both sides of this equation. So this is 5 degrees Celsius, and I'm going to do 2 times 0.51, and that is 1.02. And the units are, and then that's times x. So we had 2 times 0.51 times x. So it's 1.02 times x. And then the units that didn't cancel out are degrees Celsius. So both of these are degrees Celsius. So we're just going to, don't worry about the units because I feel like those confuse people. So 5 equals 1.02 times x. Okay, so solve for x the same way that you would in algebra class. Okay, and x is the number of moles. Okay, so that'll be your answer. All right, question 6. These are on 1.3.3, page 15 and 16, and 1.3.3, page 17 to 19. They're looking for formulas, okay? So these should be formulas, like with variables and an equal sign, kind of like that, the ideal gas law formula. And then for the last one, this is on 1.3.1, page 6 and 7. All right, so that is it for 1.5.3 test. All right, I hope that's helpful. Bye-bye.